Hello, hello, everybody. Happy Monday. My name, if you haven't joined office hours before, is Nicholas Cifuentes Goodbody, and I am an instructor at Data Camp. No, wait, hold on, let me start over. I'm an instructor at the Data Incubator, and we are partnering with WQU to bring you this wonderful course in data science. So, tell me, how is everybody doing? And what can I help you all with today? I see Ariel is here. Welcome, Ariel. Good to see you. Darsh is also here early. Wonderful to see it. Innocent is also here. Hello, hello. Glad you all could make it. All right, Mauro is here. Bibik is also here. Isa is here. Welcome. Abhishek is here. Grace is also here. Hello, Grace. Arun is also here. Hello, hello. We've got the whole group here. Adar says that office hours really makes their day despite the ups and downs in life. Well, I'm glad I can help, and for me, it's a lot of fun too. Anonymous Wolf is here. Hello, Anonymous Wolf. Sayed is also here. Welcome, welcome, everybody. Good to see you all. I just love this community. It's so great to see all of you here back bright and early on Monday. Well, for me, it's Monday morning. Maybe for you guys, it's Monday night. Christos is also here. Christos, it's good to see you. Hope all is well in Greece. I'm so glad to hear it, Abhishek, that you also like the office hours. That's wonderful. Hadija, hello. Good to see you. Christos, don't worry if you're at work. We won't tell your boss. Joshua is also here. This is the first time for Joshua to be in office hours live. So it's really good to see you. And Tarcisio is back. Welcome back. Wahaj is here from Pakistan. Welcome, welcome. Wahaj is in office hours for the first time live. Well, great. Welcome. Welcome to the group. Okay. Well, now that we're all here, let's get started. What would you guys like to work on today? I'm sorry, my handwriting is so ugly, but let's just go with it. Okay. Let's see here. Khadija has a question about random seed. We can definitely look at that. What else? What other questions would you guys like to look at? Something in the mini project or just something in general? We're getting towards the end of the course, so if there are general questions people have, I'm really happy to look at those as well. Mauro, do you have an example that you could maybe show us? Adarsh wants to do, let's see here. Well, hold on. Let me just be down. Let me see here. And then also, let's see here. Data sets. And Christos has a question about, will there be any new mini projects? Well, if you've finished all of the mini projects that have been assigned so far, it actually means you're done. In this course, there are So in this, let's see here, in this course, we have 4 mini projects, IP, VC, PW, and DW. And so if you finish those 4 mini projects, here they are actually right now. There we go. So we have IP, VC, PW, and DW. If you finish those, that means you're actually done. If you want to improve your scores on those, go for it. And I'm always happy to help people troubleshoot with those particular issues if they have. And then Ariel wants to look at ETL. Okay, so I'm going to move dynamic IPs to the end. Uh, if you want, Mauro, maybe you could post an example, like maybe there's a website you're interested in. We could look at that. Wahaj is in their final year right now. That's so exciting. That's great. And in the meantime, we'll be looking at let's see here, these other 3 questions. Okay, Arun has a question about the mini projects. I would just apply, Arun wants to know if they should apply now to Unit 2 or wait. I would just apply now. Okay, so let's get started. The first thing I'm going to do is I'm going to open up a new page here. And I'm going to go to np random. Whoop, not there. That's very strange. Hold on. Hold on. NumPy random. Okay, here we are. There we go. All right, so let's talk about the difference between random and random seed. So let's do it the following way. Okay, so first of all, let's talk about reproducibility. So in data science, the idea of reproducibility is very important. And the idea of reproducibility is that if you have a data science process or an analysis that you do, anyone else, if given your code, should be able to do it as well. Now, this can be difficult because in any data science process, there's often an element of randomness. For example, if we have a data set and we want to split it into two, we're going to use a random process to split it into two, right? If we're going to do any sort of sampling, there's going to be some sort of randomness to it. And so whenever you're doing a random process in your computer, it sets that process using, it sets that randomness using like the timing process that exists in your computer. And that way, every time it runs a random process, it'll be different. So let's open up, I'm going to open up a new notebook. So I'll open up a Python 3 notebook, and I'll just call it random. And I'm going to import let's see here, import numpy as np. Okay, great. And then the next thing I'm going to do is I'm going to go np.random random. And if I look at the documentation for random, what it's going to give me is it's going to give me a bunch of floats between 0.0 and 1.0. And I can ask for any number of floats. Hold on, let me share the screen. Apologies, Innocent. Thank you for saving me. So it returns a random float between 0 and 1. So if I type in np random.random and hit enter, I'm going to get a float. And you'll see here that I have 0.29 something something something. And if I run it again, I'll get a different number. Because again, this is a random process and it is based on a process like a timing process that's happening in the computer. And that way we can ensure its randomness. I can also get a list. If I want 5 random floats, I can have 5 here. And if I run this process a second time, I won't get the same 5 numbers. Now, this is very good in terms of randomness, but let's say that there's some sort of random component in my data analysis, and a year later, I want to rerun that analysis. Or I want to give that analysis to a colleague so that they can rerun it and check my numbers. So how do I make my analysis reproducible while still maintaining randomness? And that's where random seed comes in. So if I look up random.seed in the documentation, what this is going to do, let's actually go to random state. So what random state does is it is think of it as the placeholder for that randomness. And if what I want to do is make sure that my process is still random and at the same time reproducible, what I'll do is I will set a random seed at the beginning of my process, and that way it will always get the same result. Let me give you an example. Now, I can't remember if I need to do seed or random state, but we'll see. So let's just start by saying that every time I run my random, I get a different series of numbers. But if what I do is I set a seed, and I'll set it to 42. Let's see if this works. No, let me see here. Let me just remember how this works. NumPy set. Okay, so what I'll do then is I'm going to take this, I'm going to restart the kernel. That should help me here. So I get my array, and you can see that I have 37, whatever. And then if I run this process again, cross your fingers. No, let me start over again. I want to start with a different random function because I think this is a bad example. I'm going to start with a np random. Instead of random, I'm going to go rand int. So I'm going to merge cell above. Actually, I wonder if I do it this way. Hold on. Yep, here we go. All right. But you can see what happens is, so what I'm doing is I'm creating an array of five numbers between, 5 integers between 0 and 10. And if I set a random seed before I run my random int operation, you can see no matter how many times I run it, I'm always going to get the same answer. And so the numbers are being chosen at random, but because I set this seed, I'm always going to get the same result. So that way I can have randomness, but I can also assure reproducibility. And you can see that if I have my random seed set, I'll always get 63746. But if I remove my random seed, I'll get a different array every time. So the point of random seed is to add reproducibility to your randomness. I see Naquenti is here from Cameroon. Welcome, welcome. Good. So, Khadija, does this answer your question? Oh, excellent. So Ariel has a great question. He goes, what is 42 for? Well, when you set your random seed, you can set it to any integer. I could set it to 0. That would give me one result. I could set it to 1. It would give me another result. It could be as innocent as saying 61 or 28. The important thing, I'm choosing the number. It has nothing to do with the data. But there is kind of an inside joke in data science, where whenever you're setting a random seed, you set it to 42. It's essentially a placeholder, it's true. And the reason that a lot of people use 42 is because it is a joke. It's a joke that has to do with a science fiction novel called The Hitchhiker's Guide to the Galaxy. And Adarsh is absolutely right. It's 42 is the answer to all. So it's just an inside joke. A lot of people set their random seed to 0. You can set it to your age. And then a lot of people send it to 42 just as a joke. Okay. Well, that was fun. What's next? Icy is here. Welcome, welcome. Glad you could make it. All right. There you go. Something interesting to tell people now about 42. It's good for those cocktail parties. All right, let me go back to my list here. All right. So we've looked at random seeds. I'm going to leave dynamic IP um, to the next step here. And a next question is, what do I do when I'm exploring data sets? What's a good way to deal with data sets? Okay, well let's take a look here and think about some good examples for data sets. Let's find a data set that we can all work with. Let me just see here what we have. That's a sample. I'm looking through. Innocent's asking me to add another question to my list. Can you remind me of the question? I'm sorry, I'm a little absent-minded this morning. Garbage collection in Austin. Is that here or is that somewhere else? Garbage collection in Austin. Here's what I'm going to do. I'm going to open up a new excuse me. I'm going to open up a new notebook. Okay, hold on. I'm writing down these questions, guys. Give me 1 second. Give me one moment. Hold on. So we have all right, all right, all right. Let's see here. Grad school. And also normal distribution. Okay, I don't know if I'm going to be able to get to all of these today. I'm going to do data sets, ETL, hopefully dynamic IP. I think I'll have questions time for grad school. Let's just go as fast as we can here while making sure that everyone gets a good answer. And I promise, guys, that if we don't get a chance to answer these now, we can answer them tomorrow. So there's still plenty of time. Okay. So here's what I'm going to do. I'm going to go to a website, the University of California, Irvine, and I'm going to go to their machine learning repository. And let's see here. There's one that I really want to look at. I'm going to look at air. Well, I don't want to look at air quality. I want to look at. Hold on. Let's see here. All right, so I'm going to look at the California housing data set. Okay, great. So here's what I'm going to do. I'm going to import NumPy as NP. Oh, here it is. I'm going to import NumPy as NP. I'm going to import pandas as PD. And then I'm going to import, let's see here. I'm going to go from sklearn dot datasets import fetch California housing. All right. So here's an idea. What do we do when we first get a data set? So the first thing I'm going to do is, the first thing you do when you get a data set is you just take a look at it. So the first thing is you have to load it into memory, make sure it's clean, and then go from there. So what I'm going to do is I'm going to go data set, or data equals fetch California housing. I'm so glad to hear, Tarcisio and Ariel, that you guys have learned so much about data science. That's really exciting for me to hear. And if I look at the type of data, I can see it's a bunch. And another great tip, guys, scikit-learn. If you go to, here we go. If you go to scikit-learn, which is something you'll learn more about in Unit 2, there are a lot of great data sets that you can work with. to sort of practice your data skills. So I can start with the California housing data set, and I'll look it up here. And I'll add it to the chat. And there are a few things that I can do. The first thing I can do is I can look at so these data sets that come with scikit-learn are basically a bundle of data, and you can access them the same way you can access almost like the rows in a data frame. So I could look at description, and it's going to give me, let me print it. It's going to give me a basic description of the data set. I can also look at the, let's see here, I think it's, hold on. Feature names. I can also look at the feature names. And so it's going to give me an idea of the different features or idea, what information is in my data set. And then what I can do is I can use my pandas skills to put that stuff into a data frame. So I'll go X, capital X. Remember that for unit 2, your feature matrix, your data set is always going to start as a capital X. And so I'll put in data, columns equals data dot feature names. And then what do I do if I want to see the first 5 rows of the data? What are some things I can do to do some exploratory data analysis, or EDA? Well, I can start with head. So this is going to give me an idea of what I'm dealing with. I see that I have 8 features: median income, age of house, average number of rooms, average number of bedrooms, population, average occupancy, latitude and longitude. The other thing I can do is, what if I want some sort of summary of each of those columns? What's a good way to get a summary statistics? I could do some aggregating. Does Pandas have any tools that will help me just get a basic idea of my data? Mohammed's right, I could use describe. So I could do X describe, and that's going to give me my 8 columns, but it's going to tell me the mean, standard deviation, minimum, and maximum for all of these. And some very important things that I'm noticing already. One, for all of the features, I'll call the columns here features, I have the same number of observations. So there aren't any missing values that I have to deal with. And by the way, that's an advantage of dealing with these ready-made data sets that come from scikit-learn. The other thing I can see is that a lot of these numbers are very different in terms of their scale, right? Median income has a mean of 3.8, whereas house age is around 28, and population is much bigger, right? It's in the thousands. So already I'm getting an idea of the different shapes of the different columns. The other thing that I could do is I could go x dot plot kind equals, let me see here, pd plot kind. Well, I could go x box plot. Oh, wait, I need to import matplotlib, excuse me. Import matplotlib dot pyplot as plt. So for example, if I take this data and I just make some box plots, I can see that there's a huge difference between population and the other features that I'm looking at. A huge difference. And in fact, if I go x, let's see here, drop population axis 1, and I try my box plot again. Oh, wait, population, let's try axis 0. Oh, no, wait, it's called, it has a different name. It's called capital P population. This is a little bit better, but again, I can see that there's a huge, huge range. Let me just change the x-axis a little bit. Hold on 1 second. There we go. That's a little bit prettier. All right. So what are some other things that you guys think I could do to begin exploring this data more? What do you guys think? Give me some ideas. Okay, Adarsh has an idea of maybe I can change the y-axis to make it a little bit easier to see. Let's try this. That's a little bit better. I'll make it 75. So here we're beginning to see, we're beginning to get an idea of the data a little bit. Innocent is saying I should extend my office hours 30 minutes. I wish I could. I wish I could, but I have so many classes to teach. Maybe you can tell my bosses. All right. Now this is really interesting because let's look at this. Look at average rooms. So this is average rooms in a certain block of houses. And I can see that, the way that so this is called a box plot or a box and whisker plot. And the way it works is the green line, let me zoom in a little bit here. So the green line refers to the mean for that category. And then the blue edges of the box are going to be respectively the 25th and the 75th percentile. And then these whiskers come out, and the little black hash mark at the end would be the minimum and the maximum. And where you see these little dots, those are outliers. So they're way beyond the normal sort of distribution for this data. And this is really interesting for me because I can see that house age, for example, if I were to look at house age, so if I did X house age dot plot, let's see here. Let me actually make it a hist. I get a pretty normal looking, I mean, at least this is a distribution that I understand. But if I were to look at, for example, average bedrooms, you can see that there's this huge skew, or the data is very much skewed to the, let's see here, it's skewed to the left. So I know there are a lot of houses that have, between 0 and 10 rooms, but then there are also a lot that have more, like 60 rooms? That doesn't make sense. Maybe that's supposed to be a hotel or an apartment building. So that's giving me some ideas about how I want to uh, think about my data. What we've been doing up to now is we've been looking at these variables by themselves in isolation, house age all by itself, average bedrooms all by itself, right? And that's somewhat helpful. But another good idea is to look at these variables compared to each other. So for example, this whole data set is so you can learn how to predict housing prices. And if I look at Y, I can see here that these are housing prices. Now, these are kind of strange looking housing prices. Actually, if I look at Y, can I do describe for a, yeah. If I do Y describe, I can see that the mean is 2.06. Now, what do you guys think that means? That the houses cost $2.06? I live in California, and I know that houses do not cost $2.6, $2.06. Adarsh is close, not even $2,000. I wish they cost $2,000. And Adarsh is right. Oh, it's $100,000. That's right. Exactly. So we're talking about hundreds of thousands of dollars. Just FYI. Okay, so what I could do is I could begin plotting, instead of looking at these variables by themselves, what I could do is I could begin plotting them against each other. So for example, I could say, let's see here, how do I want to do this? So I might go, let's see here, PLT scatter X, and then I'll look at one of these particular, well, I can look at average rooms per population. Sure, let's look at that one. I love that idea. So I will go with X plot scatter, and then X will be average rooms, and Y will be, what do we say? Population. So this is an interesting plot in the sense that we see that there's a wide range of populations, but it doesn't seem, and there's a wide range of rooms, but there doesn't really seem to be a lot of connection. It kind of seems like average rooms doesn't really control. There's no linear relationship. I really can't draw a line through this data. But let's look at some other ones. So I'm going to do plt dot scatter, and I'm going to look at X. Let's see here. I'm going to look at median income, and I'm going to plot it against Y, which is housing price. Let me just label these axes. So here, the X label would be median income, and PLT dot Y label will be housing price, and then I'll put thousands. Okay. So what do you guys think about this plot? Does it seem like there's a relationship between median income and housing price? It does seem like if you look at neighborhoods, I like Adarsh's idea. If you look at neighborhoods where median income is higher, the housing prices also tend to be higher. So if I were to take a line, I could probably draw a line like this, and I could create a formula that would help me predict housing price based on median income. And I love the term that Joshua is using, right? There seems to be some sort of positive correlation, positive correlation. Whereas if I look at an, another feature in the data, like not housing price, but let's see here, house age. Here, do we see any relationship between house age and housing price? I don't know who's calling me. I assure you I had do not disturb on. But do we see any relationship, any correlation between housing age and housing price? Joshua says no, and I tend to agree. I mean, if I'm drawing a line here, there's really no relationship here. This is not going to be helpful at all. And so this is a way in which you can use exploratory data analysis, also called EDA, to decide maybe what features in your data are going to be more interesting. So if I'm trying to design a model that'll predict housing price, I will definitely include median income, but I might not include housing age because it might not be worth it. So those are some examples about how you might start looking at a data set, right? You might start looking, you might start your exploratory data analysis just by looking at the numbers to get a sense of the scale of the different numbers. And then you might begin plotting the variables by themselves. And then you might begin plotting the variables against each other. Now we don't have a lot of time left, so I just want to look at a couple things. All right, we've looked at data sets. I want to talk just briefly about ETL. So ETL stands for extract, transform, and load. And Mauro is absolutely right. I could also run a whole correlation matrix just to do it quickly. You're absolutely right. Actually, we can do that right now. Hold on. I'm sort of curious to see how that would look. Actually, you know what? I don't think we have time. I'm going to just stick with where we are. So what extract, transform, load means is that oftentimes you as a data scientist, you are dealing with data that is coming from somewhere else. So this is my data base that I'm grabbing information from, and I need to extract that data. I need to maybe do some sort of process to that data, transform it so that it's either in the proper format or there are only certain variables I'm interested in, that sort of thing. And then I'll want to load it into either a new database or maybe just into a data frame that I'm be working with. And so that's what ETL refers to. Oftentimes it doesn't sound that complicated. And for a lot of the data sets that we work with, it's not that complicated. But when you're talking about, terabytes and terabytes of data and different little edge cases and exceptions, it can become a lot more complicated. But I mean, that's the basic process of ETL. And there are people who specialize in it. I feel like a lot of people who are very good at SQL end up having ETL jobs. Um, and yeah, I mean, I don't know what else to say. And then in terms of, I know we don't have a lot of time. I'm going to cross ETL off. There was one question about grad school. I think we have time to answer that question. So someone wanted to know whether they should go to grad school right after graduating college. This is a very good question. So I have spent a lot of my life in grad school, and what I have found is that um, the people that go straight from undergrad to grad school often have a harder time in grad school because, and by the way, this is only in the US education system. It might be very different in other education systems. So take my advice with a grain of salt. But the people that go from undergrad straight to graduate school have a hard time because in undergraduate it's all about, hey, you're the student, we're helping you learn, we're helping you develop, us professors, we're here to help you. And then when you go to grad school, it's like, no, you're here to work and here to do what I say, right? And so the dynamic totally changes. You're going from sort of a happy learning experience to a much more professional environment. And for a lot of students, that's a kind of a shock. But the students that have spent a year or two working in other things before they go to grad school, one, they have more experience working in those sort of hierarchical environments. And two, they've taken time to experience more. And so for that reason, they're more certain that they want to be in grad school. And so that helps get them through it. And so the advice that I often gave my students when I was a professor was take a year or even better, 2 years off and then decide about grad school. There's no rush, you know? So that's my thought. All right, we have time for one last question. Luca's question is, how come I didn't get an error when I was running a mean calculation on a column that had NaN values? And the cool thing about something like pandas, where you can take a series and then put that dot at the end and get the mean is that it handles those NAN values intelligently. And so what it does is it just simply doesn't include them in the calculation. So that's one of the great advantages of pandas is that you don't need to worry about it. It just takes care of it for you. Okay, you guys, I know Innocent wants to do a 90-minute office hour, but I am actually going to have to stop at 1 hour. So I want to say thank you all for taking time to join in office hours with me. For those of you who I did not get a chance to answer your questions, I promise that if you come back tomorrow, I will answer them and we'll talk about dynamic IPs and normal distributions. And for those of you whose answers I did answer, I hope they were sufficient, enough to help you move on in the course. All right. Well, I will see you all tomorrow. And until then, have a wonderful day, evening, night, and happy, happy data science. Bye, everyone.